Solar system. Have you ever heard about it? Of course we all have listened to something about it, but if not, let me introduce. Our solar system orbits the center of the Milky Way galaxy, which means that we are in one of the galaxy's 4 spiral arms, and is made up of a star, 8 planets, and countless smaller bodies such as dwarf planets, asteroids, or comets. It's called the solar system because we use the word solar to describe things related to our star, after the Latin word for sun, solis. Now that we know what this video is about, let's move on.
As we mentioned, the solar system has 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Let's start with Mercury. Mercury has an unusual internal structure. Most of its inside cover is taken up by a large ball of iron. It has a rotation period with a duration of 1,416 hours. Its obliquity to orbit is 0.034, and the translation period lays 88 days, and its equatorial diameter is 4,879 kilometers. The next one is Venus. The Venus internal cover is made of solid iron and nickel. It has a rotation period with a duration of 5,832 hours. Its obliquity to orbit is 177.4. The translation period lays 224 days, and its equatorial diameter is 12,104 kilometers. Next one is Earth. The Earth's internal structure includes its atmosphere and hydrosphere and consists of following layers: crust, mantle, outer cover, inner cover. It has a rotation period with a duration of 24 hours. Its obliquity to orbit is 23.4. The rotation period lays 365 days, and its equatorial diameter is 12,756.
I will start with Mars, a planet composed primarily of iron and nickel with about 16 and 17% of sulfur. Its iron sulfide core is partly fluid and has twice the concentration of lighter elements than Earth. The core is surrounded by a silicate mantle that forms many of the tectonic and volcanic features of the planet, but now appears to be dormant. Besides silicon and oxygen, the most abundant elements in Martian crust are iron, magnesium, aluminum, calcium, and potassium. The rotation period of Mars is approximately 24 hours and 37 minutes. Mars has an obliquity to orbit of 25.2 grades. Mars has a translation period of approximately 687 days. Mars has an equatorial diameter of 6,792 kilometers. Jupiter's composition is mostly hydrogen and helium. Deep in the atmosphere, pressure and temperature increase, compressing the hydrogen gas into a liquid. This gives Jupiter the largest ocean in the solar system. An ocean is made of hydrogen instead of water. Jupiter has a rotation period of approximately 9 hours and 65 minutes. Its obliquity to orbit. Jupiter has an obliquity to orbit of 3.1 grades. Translation period, days. Jupiter has a translation period of approximately 31 days. Equatorial diameter. Jupiter has an equatorial diameter of 142,984 kilometers. Saturn. Internal structure. Saturn is composed primarily of the light gases hydrogen and helium. It is considerably more depleted in these gases compared to Jupiter. Saturn has a rotation period of approximately 10 hours and 34 minutes. Saturn has an obliquity to orbit of 26.7 grades. Saturn has a translation period of approximately 10,747 days. Saturn has an equatorial diameter of 120,536 kilometers.
Then is Uranus, which consists of 3 layers. first a rocky silicate iron nickel core in the center, then an icy mantle in the middle, and finally an outer gaseous hydrogen helium envelope. It has a rotation period with a duration of 17 hours 14 minutes. Its obliquity to orbit is 97.8 degrees. The translation period lasts 30,589 days, and its equatorial diameter is 51,118 kilometers. And last but not least is Neptune, the solar system's most distant planet, which has a stormy atmosphere composed mostly of ice surrounding a rocky core. Astronomers classify it as both a gas giant and an ice giant. It has a rotation period of 16 hours 6 minutes. Its obliquity to orbit is 28.3 degrees. The translation period lasts 59,800 days, and its equatorial diameter is 49,528 kilometers.
The lunar phases. The moon takes almost the same time to rotate on its own axis as it does to complete an orbit around the Earth. So from there we always see the same side of the moon, but both sides receive light as the moon orbits. So the moon revolves around the Earth, taking approximately 29 days and a half days to complete one revolution. For this, the amount of light portion that it will be received will be greater or less depending on what moment of the translational moment it is at. So the moon goes through different phases that are repeated cyclically because as it rotates around the Earth, the degree of the exposure to the sun change. Also, the phases of the moon should not be to the shadow that our planet casts. It's the opposite. It is because the light of the sun. So in the moon phases we have the new moon, the waxing crescent, the first quarter, the waxing gibbous, the full one, waning gibbous, last quarter, waning crescent, and again the new. It's a cycle. So as we can see in the new moon, you can see anything. It's like the invisible face of the moon. The moon doesn't usually pass directly between the Earth and the sun due to the inclination of the moon's orbit. Then also we have the waxing crescent. The moon continues its orbit and shows more and more illuminated portion than the first quarter. It's a fun fact because some people say that this is like the half of the moon, but no, this is not the half of the moon. This is the half of the moon. Then we have the waxing gibbous, then we have the full moon, then we have the waning gibbous, and actually in the full moon this is technically the real half moon, and we have the last quarter and the waning crescent. So this is the lunar phases.
Now that we have focused a little more on Earth, we have to go into it and ask ourselves, what causes the seasons? Well, many people believe that the Earth is closer to the sun in summer, and for that reason it is warmer. They also believe that it is farther away from the sun during the winter. Even though this idea makes sense, it is incorrect. But before I tell you how the seasons occur, we have to understand that the Earth is not immobile in space, but performs two different movements: rotation on its own axis, which motivates day and night, and translation that performs around the sun. Now that we know that, we must also understand that the Earth rotates on its own imaginary axis, and that the Earth follows an elliptical trajectory around the sun. The rays of the sun do not affect in the same way in all regions of the Earth, and do not always in the same way in the same region. In fact, the two hemispheres are alternatively exposed to a great amount of sunlight, and this is the reason that we distinguish 4 seasons in the year. So the seasons of the year are not caused by changes in distance. They are basically due to the fact that the Earth's axis does not exactly form at the right angle with its orbit, but has an inclination of 23 degrees, an inclination that remains parallel anywhere in the Earth's orbit. Since the axis always points the same direction anywhere in the orbit in which the Earth is, its northern part sometimes leans toward the sun and sometimes it's so far away from it, and that causes the season.